Okay, let's just jump right in. We are connecting two fields that you probably never expect to see in the same sentence.
Right.
We're talking 1970s architectural philosophy and cutting-edge AI research.
It's a fascinating intersection.
It really is. Our focus today is the work of a design theorist named Christopher Alexander. And this man had really a single relentless goal his entire life. He was searching for the secrets to beauty, to wholeness, to this deep spirit he called the quality without a name.
You won.
Q1. He believed that to get there, to make great design, you had to master this really difficult concept he called well-ordered complexity and complete reject the sterile, oversimplified spaces we live in.
Mm.
So our mission today is kind of twofold. First, let's try to understand Alexander's search for this Q1. And second, we want to explore how the latest AI research, specifically this push for deliberate reasoning, surprisingly validates or maybe even challenges his big ideas about what makes a space feel alive.
And what's so interesting here is that Alexander's whole quest, he was fundamentally philosophical. He was trying to overturn this huge split in Western thought, the separation of fact and value.
What is measurable versus what ought to be?
Exactly. He insisted that qualities like harmony or well-being in a building, they had to be just as objective, just as measurable as the width of a window.
That's a huge claim.
It is. And we're going to see how these massive AI models, for all their environmental cost, are now being built to do what psychologists call system two thinking, this slow, deliberate reasoning.
Okay.
And that is precisely the kind of complex thinking Alexander said we needed to get beyond just, mechanical engineering and actually achieve living design.
So let's unpack that. Alexander's foundational idea, he wasn't just talking about, pretty buildings.
Not at all.
His goal was a process that would create environments with real beauty and life. And he saw the modern world as just a spectacular failure because it embraced oversimplification.
Yes. Reducing everything, all our complex human needs, down to these standardized, easy-to-build boxes.
And that pursuit of complexity, that's what led to his most famous work, right? The pattern language.
Absolutely. And the story behind it is great because it's so pragmatic. It actually started with a government RFP, a request for proposal.
Oh, really?
Yeah, from the NIH, of all places. They were basically asking, does the environment we build actually affect our health and well-being?
A question we're still asking today.
We are.
Yeah.
And Alexander and his team, they admitted it was an unknown. But they set out to define the structures that might create that well-being. And the result was this incredible catalog of 253 patterns.
And these are not just like blueprints.
No, they're abstract instructions. They're derived empirically from what works, and they're designed to solve these recurring problems in how we arrange space to support human life.
I love that for something so abstract like Q1, the instructions are so concrete. Can you give us an example, something that defines a real human need through architecture?
A perfect one is 6-foot balcony, pattern number 167.
6 feet. That's very specific.
It's incredibly specific and for a reason. A balcony that's too narrow, it's just a ledge, it feels precarious, you can put a plant on it, and that's it. But 6 feet, that gives you a sense of ease, of safety.
You can actually use it.
You can use it. 2 people can sit and talk, you can have a small table. But crucially, it connects the private life inside with the public life of the street. It invites that connection. It solves a social problem with a physical dimension.
Right, so it's about the affordance of the space, not just the measurements.
Precisely. Another fantastic one is entrance transition, pattern 112. Alexander realized that just a door, where you're immediately inside or outside, isn't enough psychologically.
You need a buffer.
You need a buffer, a threshold, because you need time and space to sort of shed your public persona and get ready for private life. He said the transition area has to be big enough to destroy the momentum of the closiveness, tension, and distance we carry in from the world. It's an instruction born from a deep psychological need.
So the pattern language gives us the manual for the parts. But the whole system is driven by this almost spiritual goal, Q1, this elusive spirit of life. I mean, it sounds so subjective.
And that is the paradox. It sounds mystical. A lot of critics just hear that and dismiss it immediately.
Right.
But Alexander was absolutely adamant that Q1 was not subjective. It wasn't personal taste. He believed it was an objective quality, scientifically precise, that our own evolution has tuned our brains to recognize.
So how do you achieve it then?
Through what he called exquisite exactness. By reckoning with all the complex forces acting on a single space.
Okay, exquisite exactness. What does that mean in practice?
It means you can't ignore complexity. Say you're placing something as simple as a bird feeder. You have to account for the wind, the sightlines from your window, safety from predators, the local birds, all of it.
All those forces and constraints.
They have to be resolved perfectly. If you get it wrong, the bird feeder just feels off. The QAnon is gone. It has to be exactly right. A holistic solution for it to feel alive.
And this idea, this insistence on making experience an objective fact, that's the philosophical bomb he threw at the design world. You said earlier he traces it all the way back to Descartes.
That's his origin story for the problem, yes.
Mhm.
Alexander argued that Descartes' method for understanding reality, break it down, isolate the parts, pretend the world is a machine,
Hmm.
it fundamentally destroyed our ability to design.
How?
Because if reality is just a machine, then only mechanical measurements can be considered fact. So the width of a door is a fact. You can measure it.
Okay.
But the quality of that door, does it feel welcoming? Does it feel safe? That gets dismissed as just opinion, as value.
So fact and value get split apart.
They're severed. And modern architecture, obsessed with efficiency and measurement, it chose fact and just abandoned value.
So the real point isn't just that he disliked ugly buildings. He was trying to inject a kind of moral objectivity back into physics. He wanted our experience to be a measurable input.
Yes, exactly. And his solution, which he laid out in his huge 4-volume work, The Nature of Order, was this radical alternative, living geometry. He claimed every part of space, a brick, a stone, a whole city, has an objectively existing, measurable degree of life.
Wait, but let's be honest for a second. Doesn't calling Q1 objective just risk replacing one dogma, like modernist minimalism, with his own set of rules?
Right.
The 15 properties?
That's the critical question, isn't it? He would argue no, because he believed living geometry is rooted in how our own perception actually works. And the core component of it is the center.
The sector.
A center is just any configuration that stands out, that coheres, that intensifies other centers around it.
And the power is how they relate to each other.
Exactly. They're recursive, centers are made of other centers, and they organize the space. He does this famous demonstration. If you put one single dot on a blank piece of paper, you don't just create one center. You immediately create at least 20 latent perceptual centers. There's the dot itself, sure, but also the halo around it, the 4 corner regions, the rays shooting out horizontally and vertically. Even the white cross made of the negative space.
Wow. So even the empty space, the absence of the dot, creates something you notice. Living geometry is about maximizing the relationships between all the things we see.
That's the engine driving it. And to do that, he developed his 15 fundamental properties. These are the tools. Things like levels of scale, strong centers, deep interlock, and ambiguity.
The toolkit for creating this living structure.
Exactly. And environments that have these properties are empirically shown to make us feel calmer, to promote cognitive engagement, and to literally reduce our stress.
So if this blueprint for well-being exists, why does so much of our world feel so structure destroying?
Alexander argued it's because contemporary architecture prioritizes ideology minimalism, industrial modernism, over actually checking if it works. He called it invention without verification.
It's dogma.
It's dogma.
Mm-hmm.
It ignores the scientific data about human health and builds these alienating places because it's just following a trend instead of evidence from real human experience.
Okay, this brings us perfectly to the bridge. Alexander demanded we master complexity in the real world. So if we look at the most complex intelligent system we've built, AI, does it show us that mastering this kind of organized complexity is even possible?
It's a perfect mirror. I mean, the giant leap in AI recently has been this move beyond what's called System 1 thinking.
The fast intuitive stuff.
Right, the pattern matching it's pre-trained on. The leap is into System 2 thinking, which is slow, deliberate, cognitive reasoning.
Like the AlphaGo analogy.
The AlphaGo analogy is perfect. To become superhuman, the AI couldn't just rely on its stored knowledge. It had to literally stop and think during the game. It had to run thousands of simulations, score the outcomes, a deep search before it moved. That's System 2.
And that's the challenge for LLMs.
That's the huge challenge for LLMs. How do you build that deep search, that value function, when you're dealing with messy, open-ended problems? Things like diagnosis, legal analysis, or, design.
And cognitive scientists are finding that when LLMs try to tackle these ill-structured problems, they seem to be missing the process for complexity, even with all that knowledge.
That is the crucial misalignment. Researchers tested these models using a taxonomy of 28 different cognitive elements, things like self-awareness, abstraction, different reasoning operations. And when they face these messy problems with no single right answer, the models consistently narrow their approach. They default to rigid, shallow strategies.
What does a rigid strategy look like there?
Overwhelmingly, they favor sequential organization and forward chaining.
Meaning what?
Imagine a programmer who just starts writing code line by line without first making a plan or a flowchart. They're just applying knowledge in a straight line, trying to solve the problem with the first bit of info they see.
I see. So what's the successful strategy?
Well, the failure point is that human success on these problems design, diagnosis, correlates with behavioral diversity, using lots of different representations, hierarchical, network, spatial. For example, in a diagnostic problem, a successful human strategy is scoping first. You use selective attention, you align your knowledge, before you try to chain forward to a solution.
And the AI just rushes ahead.
The AI rushes to the forward chaining and fails because it hasn't actually understood the complexity, the constraints, the relationships within the problem.
So in a way, the LLMs have the parts for Alexander's complexity, but they lack the meta-awareness, the cognitive control to unfold it correctly, just like the architects ignoring the human constraints.
It's the exact same flaw in process,
Yeah.
which brings us to the real-world cost of all this digital thought.
Right.
What does this System 2 calculation actually cost us physically?
It's a huge environmental trade-off. I mean, humans are slow, but we are incredibly energy efficient.
Right.
AI has a massive and growing up footprint.
Mass.
Training a model like GPT-3 took something like 12,287 megawatt hours. That's over 500 tons of co-euros. And running them is, well, thirsty. Inference uses millions of liters of water for cooling. Every 20 to 50 queries you run on ChatGPT uses about half a liter of water.
That's astonishing. Compare that to a human writer using maybe 0.1 kilowatt hours per page. But the equation flips when the complexity scales up.
Right, totally flips.
Look at DeepMind's AlphaFold. It used over 1,000 megawatt hours for training, a huge cost. But once it was deployed, it predicted the structures of hundreds of millions of proteins.
A task that would have taken human labs.
Centuries, literally centuries. So it shows you AI's incredible efficiency for very specific, very large-scale, computationally hard tasks.
Okay, so if AI is mastering the computational complexity, and Alexander demanded we master the geometric complexity, can one help us with the other? Can AI actually help us build the living structure he was talking about?
I think it's the key. It provides the technology to finally make his argument mainstream, to have objective verification. We can now use AI as a design tool to both evaluate and generate living geometry.
How does that work?
Well, diagnostically, you can feed an image of a new building or a city plan into an AI and ask it to evaluate the spatial patterns. Does it have strong centers? Is there deep interlock? Does it feel whole?
And you could use it to generate designs, too, to get away from the dogma.
Exactly. If you use the 15 properties as your prompt, you're guiding the AI directly toward these principles of living geometry. You can bypass all the subjective ideological fads, the minimalist trends that are so entrenched in architecture schools. You're basically giving the AI Alexander's rulebook.
And you're telling it to generate environments that are proven to work for us. Which brings us back to the value side of his equation, the measurable human impact. What's the science that backs up these restorative effects?
Oh, the evidence is really compelling, and it's growing. Environments with living geometry, so things with fractal patterns, biophilic features, they have measurable restorative effects. We see lower cortisol levels, reduced activation in the amygdala.
The brain's fear center.
The brain's fear center. The medical evidence is really powerful. Studies have shown for years that hospital patients recover faster, they need fewer painkillers, if their room just has a view of a natural scene, an environment that's full of these coherent fractal qualities.
So it's not just a feeling, it's physiological.
It's physiological. And this type of geometry also stimulates the brain's reward circuits. It creates a relaxed but alert state. It enhances alpha brain waves. And that state is known to be perfect for creative insight and divergent thinking.
So Alexander's grand goal of making human well-being an objective, measurable criterion, it's not just a philosophical dream anymore. It's actually becoming technologically feasible with AI that can diagnose and even implement these very specific life-enhancing geometric structures.
So, to sum it all up, we've traced this really profound line, I think. We went from Alexander's quality without a name and his critique of simplistic modern design all the way to the deep, organized complexity that's required for both great architecture and for advanced AI reasoning.
Yeah.
Alexander showed us that beauty requires this exquisite exactness, and now modern cognitive science is mapping the exactness needed for that kind of true System 2 thinking.
And the biggest takeaway for me is how that loop closes. Alexander's whole philosophical fight to unify fact and value, to make our well-being a scientific fact, is finally being empowered by technology that can computationally recognize those same patterns. The AI is the scientific mirror we needed to see the life in a space.
Well said.
But let's end with a provocative thought for you to think about. Alexander's whole philosophy was about unfolding order, developing a whole through these progressive steps, all tailored to the context. And we just discussed how modern AI fails on these messy problems because it defaults to rigid, shallow, sequential thinking. So if these advanced AIs only succeed when we explicitly guide them toward the successful structures of human reasoning, abstraction, planning, flexibility, what does that tell us? Should the ultimate lesson here be that we need to apply the structures of successful human thought, self-awareness, planning, that flexible structure to how we design our physical world? Maybe we need to design our thoughts before we can ever hope to design our homes.